So again, to be perfectly honest, I really don't have any use for what's called the geometric mean. All right. Um, Now, I'm not even real sure why they call it the geometric mean, honestly. Um, I always just use proportions. All right. And so the geometric mean is supposed to be set up as a proportion. All right. And you will notice that the proportion or the geometric mean has to do with the similar triangles in a right triangle. All right. But I'll address that in a few minutes. All right. Now, again, I have never seen on any standardized tests anything more other than in this section 8-1 when they talk about a geometric mean. So what exactly is the geometric mean? All right, it is when you write this as a proportion. All right, it's going to be 2 over x is equal to x over 8. Like I said, it is a reference to a proportion in the right triangle. All right. Now, you can easily summarize this. Then when you cross multiply, you get what? X squared equals what? 16. Right. So you're right. Now be careful. X could be what?
4 negative.
Yeah, thank you. For those of you guys who remember that. X could be plus or minus 4. All right, so then I always get people who ask, well, can I just multiply them and take the square root? And that would be what? That would be yes. All right, and let me say it one more time because again, I don't like to just give you information just to remember it's the geometric mean. All right, the geometric mean is a proportion that will help you solve the right triangle below. I just don't call it the geometric mean because I just think it's pointless to say that. All right, number 2. All right, now instead of writing the proportion, we are just going to say what? X squared equals 9 times what? 36.
300.
No, 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 no. Obviously, that is just 18.
Wait.
All right. We would say obviously x is equal to plus or minus 18. Now, those of you guys reaching for your calculators, you can just slap yourself a little bit. Say stop with the calculator. How did I know that was plus or minus 18? Wow, thank you. The square root of 9 was what? Square root of 36. 3 times 6. That's what you're reaching for your calculator for. Okay, I got you. All right. I agree with you. All right. That's why you don't need a calculator. You need to work on your math facts. Square root of 9 is what? 3, right? Square root of 36. We'll call today 6. All right. Anybody have any problems with that being plus or minus 18? All right, let's see how much fun we can have with number 3. So we're going to say x squared equals not 28. We're just going to say 4 times 7. So we can say x is equal to what? Plus or minus 2 radical 7. And part of the reason why I don't just skip this all together is because it gives me a little chance to review with you square roots. All right, anybody have any questions with 2 radical 7? Nobody? All right, let's take a look at number 4. All right, so now we can say x squared equals not 50, but we're just going to leave it as 5 times 10. And then everybody should be able to say, well, we just know that's going to be plus or minus, thank you, 5 radical 2. Now, how did I know it was 5 radical 2? Because there was a common what? There was a common 5. So we just pull out the 5 and leave the 2 behind. Is everybody okay with this? All right. So now over here, everybody should be able to just say x squared equals what? 28 times 14, and then x equals plus or minus what? 14. Some of you are doing with Yeah, 14 radical 2, right? Yeah, 7 is possible, but there's a bigger number, right? 14. Now remember, this is a review of radicals. So if you're a little slow, I understand. Or it's been a while. So don't sit there. If you're not keeping up with me, just say, hey, just slow down a little bit. Show me something. What am I missing? Anybody have any issue with that? Everybody's good? All right, let's try one more then. So we all should be able to just look at that and say x is equal to what? Say it again. No. No. Thank you. Rankin, you finally got a couple right answers. What do we got? Plus or minus 6 radical 7. Don't forget the plus or minus. All right, don't forget the plus or minus. Anybody have any issues? If you do, just see Harris after class. He'll be able to fill you in. All right, thank you, Harris. All right, now, again, how easy is this stuff down here? Simple, simple, simple. And of course, I say it every year, and this is the only section that kids have the most difficult time with. All right, so again, I would like everyone to look carefully and listen carefully. Don't think you know. All right, please don't think you know. All right, I draw a right triangle, and then I draw the altitude from the large or from the right angle to the hypotenuse. So I'm going to draw this. That's the altitude. So it creates a right angle. So how many triangles do you see? How many right triangles do you see? So what's true about all 3 of those triangles? They are all similar. They are all similar. How do I know they're all similar? No, not all right triangles are similar. They share 2 angles. That is the best example, all right? They share angles, all right? Everybody, like you said, they're right triangles. So that's 1 angle, correct? So now what I want to do is I want to highlight to show you something. The large angle, or not the large angle, but the large triangle. Now I'm going to highlight the small triangle. And besides the right angle, what angle do they share? B. They share B. So that makes them what? That makes them similar. All right, now what I'm going to do is I'm going to highlight the other triangle, this small one. All right, now with the small and the medium triangle, with the small and the medium, which one do they share? Do they share anything besides the right angle? No. So that one's a little bit harder to see. All right, that one's a little bit harder to see. But if you look at the large one and the small one, they share A, right? So now what I want to do is, this is how I finally figured out. All right, because in my opinion, it's just hard to see sometimes. Now, I'm going to address it 2 ways because some people like this. All right. This right here is called the what? That's called the hypotenuse. This right here, I'm only looking at the large triangle. And again, honestly, guys, you don't have to write this down. I promise you it'll be crystal clear in a minute. And sometimes I think it's better just to watch, because we're going to do it how many times here? 4 more times. All right. So watch what I'm saying. Watch what I'm saying. I think it's better. All right. So CB is considered LL. What does that mean? Large leg or long leg. That's correct. And so AC is considered the what? The short leg. All right. Everybody with me on that? So now I'm going to look at the middle triangle. All right. This is why it's hard. This right here is called the what? Hypotenuse. DB is called the what? Long leg. And DC is called the what? Short leg. Does everybody see that? All right, now I'm going to the short triangle. AC represents the what? Now you guys see the problem, right? Because I'm going to refer to AC, and some of you are going to say, well, that's a hypotenuse. And I'm going to say, no, that's a short leg. And you're going to go, no, it's not. It's a hypotenuse. Right? It just is a matter of what triangle are you looking at. Is everybody with me? Right? Now, AD would be called a what? Short leg. Notice that doesn't really overlap. But CD is a what? Long leg. And look at the long leg and the short leg, right? It could be either one, depending upon what triangle you're looking at. Is everybody with me? All right. So that's why this can be very confusing to the eye. All right. Now, what is true about a hypotenuse to a long leg? It is equal to a what? Hypotenuse to a what? Long leg, which is equal to what? A hypotenuse to a what? Long leg. Does everybody understand that? Right, so they're going to give you pieces of the puzzle, and you got to figure out where the piece goes. Also, I could just go ahead and say, all over what? The short leg, over the short leg, over the what? Short leg. So you can say hypotenuse to short leg. You can say long leg to short leg. You could, any combination, as long as you set up the proportion properly, it will give you the right answers. Everybody with me on that? Now, sometimes when you draw a right triangle, and I don't see one here. I don't like any of those. But on the SAT test, right, recently there was one like this. And then it did this. And if you just learn short leg, long leg, what's the problem now? It's kind of hard to say which one's a short leg and which one's the long leg, correct? So occasionally the triangle will be so close that it's kind of hard to see. So if you're only looking at it as far as from a short leg to a long leg to a hypotenuse, it's a little bit hard. All right, so then what I show kids is this is really, to me, what made it simple. All right, so I'm going to say this angle right here is 20 degrees. Is it 20 degrees? Yeah, because I said it was 20, right? But seriously, does it have to be 20? You make it whatever you want to make it. All right, now why am I doing that? Because I'm trying to show you visually how you can tell how simple it is to see what corresponds to what. So what does this DCB have to be? That has to be 70. Does everybody agree with that? And then this ACD has to be what? 20. And then angle A has to be what? Now do you see how it's has to be similar triangles now, right? Everybody okay with that? All right, now for those of you guys who are brilliant, you should say, well, instead of just saying that, right, here's what I want you to say. Well, this angle right here, I'm going to call X. So what's this angle right here? No. No. Harris, say something smart again today. What is that angle? Oh, Brady knows. Thank you, sir. That is 100% correct. That is 90 minus X. So now if that's 90 minus X, what is this angle right here? Thank you. And then what's this angle A? There you go. If that's how you prefer to do it, a little bit more advanced, that's how you can prove that they are what? That they are all similar triangles. So everybody agree with that now? All right. So if you understand that, now you should be able to write similar triangles. All right. So we're going to start with the large triangle now. And I'm going to say, I always like to start out in alphabetical order. So we're going to say triangle. I always like to do the small, and then I like to do the medium, then I like to do the large. And if you can do these next four problems, then the problems down here where you have to solve everything are what? Easy, simple, simple. All right. But again, the hard part is finding the similarity statements. All right, so here we go. And I promise you it's super simple. All right, here we go. So I have triangle A, B, C is similar to who said wait already? We're doing alphabetical order, A, B, C. That's how I got that. A, B, C, right? That's what we're going for. Now I'm going to the middle triangle. Now A is the 90 minus X. So what does the 90 minus X correspond to? C. B is the what? X. So on the middle triangle, it's going to be B goes to B. Thank you very much. And then C is the right angle, but for those of you guys who are brilliant, you already used 2 letters, so it's got to be the only one we haven't used, which is what? D. All right. Now, again, this is why sometimes I tell kids it's sometimes better just to highlight what you're looking at. All right. I don't care. Some of you are better visual than others. Look, you just can't mess that up. Right? If you mess that up, your proportion is going to be all wrong. All right. Now I'm done with that. So now I put similar to, now we're looking at the small triangle. Now, again, we said A was the what? 90 minus X. B was what? X. And C was 90 degrees. So now triangle. I'm going with 90 minus X on the small one, which is A. And then the X is C. And then the right angle is. Now, again, guys, I say this every year. To me, that is just so simple. I don't know how people miss it. Every year, though, people, I just don't know why. All right, I really don't. All right, there's lots of options. You can convert them to numbers. You can convert them to X and 90 minus X. You can say long leg, short leg, hypotenuse. Any way you want. All right, just set up the proportion correctly. Yes, sir. It's all the same, right? Because this again is 90 minus X. This was X and this was 90. 90 minus X, X, and 90. Agreed? Right? Okay, here we go. Let's check out number 8. All right. So let me give you a minute. All right. Everyone try to do number 8. And please get it right. All right. If we get it right, then guess what? We don't have to do the next one. All right. If you miss it, we got to do the next one. Are we trusting in Davis?
No.
What? What? How rude. Davis, just for that. I think you should just tell me the wrong answer so we make him do all of them. All right. But no, Davis has a good heart, so he would never do that to you guys. He would never play a joke on you guys. So here we go. Now, remember, Davis, I'm expecting alphabetical order. So the large one. Are you sure? A, B, C, D, F, G, H, I, J, K, L, M, N. Yes. Triangle. L, M, N. Very good. Similar. All right, we're going for the middle one now. Hold up. All right, no. Don't say anything or we have to do all the work. All right, we're going for the middle one. Shh. Triangle. L, what? NP is similar. Shh. Nope. Triangle. Thank you. Shh. Wait a minute. I can't hear him if I don't hear him correctly. Go. NMP. Does anybody agree with that garbage?
Yeah.
All right. Anybody have any issues with that?
No.
Anybody? Come on now. Ruffin, stop. You Ruffin.
You didn't say 90.
All right. Okay. So is everybody agreeing? That's simple, right? Simple, simple, simple. All right. Now, for me personally, I like to use the similarity statement, all right, and setting up the proportions. All right, so let's jump down now to question number 11. All right, now, here we go. Let's walk. We have to figure out what x, z, or we got to figure out what x, y, and z are. All right, now, let's identify 3 here. 3 is the what? Short leg. Z is the what? Long leg, or it is the short leg of the right side, correct? And then X is called the hypotenuse for the triangle on the left. This is how I personally do it. All right, unless I can't tell what's a short leg and a long leg. All right, now the right side or the right triangle, what is 9? 9, now here's why we like this. 9 is the long leg. Hold on a second, let me change this. Hold up a second. Long leg. And then Z is the what? Z is the short leg. All right. Now, there is obviously a pattern, right? There is. And it always works out exactly the same. So once you see it, you see the pattern and you can just set up the proportions. But it takes a while before you see everything. Right? So right now, this is what they were trying to refer to up in the previous problems where we were doing the geometric mean. All right. I personally don't see it, and I never will say that to you. All right. But in this case, if we set it up, it's going to be short leg over long leg. So I have 3 over Z is equal to 3 is the short leg to long leg. It's going to be Z over 9. Everybody okay with that? And now, of course, we just look at that again and we just say Z squared is equal to 3 times 9. Now, can Z be negative? No, because it's talking about a distance, right? In our equation, it can be negative, but because we're measuring something, it can't be negative. So we just say Z equals what? 3 radical 3. All right. Now I do think it's important to come up here. All right. And we could now just change this to 3 radical 3. All right. Now, in my opinion, from here, I hated setting up proportions. I hated it. All right. So from here, I would just personally do what? A squared plus B squared equals C squared, right? But guess where A squared plus B squared plus or equals C squared is being taught? That'll be tomorrow. All right. It's kind of silly. I don't understand it. This is the only part of the book that I feel like they could do a better job on. All right. Because again, we've known Pythagorean theorem since literally 6th grade. All right. So it shouldn't be a big deal. So if you want to set it up as proportions, you can set it up as a proportion. All right, so let's do that. All right, since we're talking about this particular section. And then those of you guys who are like, forget that. I'm not thinking that hard. I'd rather just do A squared plus B squared equals C squared. That's my feeling also. But I want to show you the proportion. All right, so now I know this. I have a hypotenuse and a what? Short leg. So I'm going to label that hypotenuse to short leg. And I'm going to say that's what? X over 3. Everybody agree with that? So now I just have to find a hypotenuse and another short leg. Can I do the triangle on the right? No. Because I have the hypotenuse is another what? Variable. Is everybody hearing me on that? Right? So I can't choose the one on the right because it has another variable. So that means I'm stuck with the big triangle. So what's the hypotenuse of the big triangle? 12. And the short leg is what? X. So in many ways, that's a little bit easier. So now we just say X equals, because we're brilliant, X equals 6. All right, so now I'm going to come erase this over here, and I'm just going to put a 6 here. And now I'm looking at another proportion where y is involved. So y is a hypotenuse, right? So I can say, would I do 3 radical 3 or would I do 9? 9. So I want the hypotenuse to the long leg, which is y over 9. And now I need a hypotenuse and a long leg. 6 is a hypotenuse. Uh-oh. Then that'd be 3 radical 3. So I prefer not to do that one. But can you use that one? Yes. But let's do a hypotenuse and a long leg of the big triangle. 12 over, there you go, 12 over y. Everybody okay with that? So now, of course, we're going to say y squared. I'm not really going to multiply 9 times 12 because I don't want to break it down. So I know that the square root of 9 is what? What perfect square is in 12? 4, so that becomes a 2. And then what was left behind? 3. So y is what? 6 radical 3. All right, is everybody okay with that? Everybody okay with that? Any issues? Yes, ma'am, go. Okay, so in your head, here's what you should be saying. 9 times 4 times 3. And the square root of 9 is, square root of 4 is 3 is left behind. Does that make sense now? All right, we're just multiplying. Okay, yes, sir. 3. Well, we're going to get to that also. All right, I'm going to show you what's called a 30, 60, 90 triangle. All right, these are special right triangles. That's coming up also. All right. Yeah, but not right now. Not right now. I promise you, you're right, but we're going to show you why you're right later. All right, now what I'm going to do is, just because I want to show you about the Pythagorean theorem, because we found that 3 radical 3, I'm just going to do this. Let's slide this over out of the way. And z was 3 radical 3, right? Isn't that what we said, 3 radical 3? All right, so let's practice Pythagorean theorem. So this would be, I'm solving for x, x is the hypotenuse, so we'd say x squared equals, what's 3 squared? 9. Now be careful, plus, what's 3 squared? What's 3 squared? What's the square root of 3 squared? 3. Now this is where you're trying to get a little smarter now. All right, it's been a while, right? Everybody okay with squaring 3 radical 3? If I square this quantity, you're squaring the 3, which becomes a 9, and then the square of square root of 3 is just 3, right? So now I have, what? I'm doing the Pythagorean theorem, right? Shh, I'm just showing you. Because some people, I personally would just do the Pythagorean theorem from here, right? I hate trying to set up the proportions. I hate it, right? So I just, once I calculate 2 sides, I know the third side is a squared plus b squared equals c squared. You with me now? And I'm just trying to show you it's the same thing. And if you're good with numbers, it's easier, in my opinion. So this now becomes x squared equals 36, right? So then isn't that what we said this was 6? Right? And now over here again, right? Now 3 square root 3, well, let's do this now. So this would be 3 radical 3 squared plus 9 squared equals y squared. Is everybody okay with that? Now remember, I tried to show you something earlier. This has a common what? 3. right? So this over here, I'm going to pull that out. Come on now, please listen. Please listen. 9 is 3 times 3, right? So I'm going to grab this 3, and I'm going to grab this 3, and I'm going to put it over here as a what? As a 3. You're multiplying by 3. All right? So now what's the square root of 3 squared? 3, right? Plus what's 3 squared? 9. And then we're going to take 3 plus 9, which is square root of 12, which is, what is it? Wow, that was a bunch of mumbling. 2 radical 3, right? But then there was also times 3, right? So hopefully I didn't confuse you. That's 6 radical 3. Isn't that what we said it was before? 6 radical 3. Now let's just say for whatever reason, you're like, man, that's just crazy. I'm never going to be able to do that. All right, so let's just go back to where it was. And what is 3 radical 3 squared again? 27. 9 squared is what? 81. 81 plus 27 is 108 equals y squared. 108 is obviously 36 times 3, right? Square root 6 radical 3. Same thing. All right, is everybody understanding that? All right, so does it matter which way you want to do it? No, I don't care. I personally like to find one side. That's one thing we have to find. And then from there, we have to use a squared plus b squared equals c squared. All right. Now, I would like to show you this, though. Whenever you split the hypotenuse, all right, if you can remember this, whenever you split the hypotenuse, that's where you're going to use what? X over 4 equals 15 over x. That's just the basic. All right. All right, is everybody okay with that? All right, let me try to find something like this guy right here. Everybody look at 14. Everybody look at 14. All right, here we go. Now, to me personally, when I look at that, I would just say y is automatically what? I would just look at that and say y is radical 29. Right, that's one less thing I have to worry about. I'm not making a proportion to solve that. Does anybody have any issues with that? Radical 29. That's how easy that is. Now, I like to look at, I know there's a relationship between these 3 numbers, always. All right, so x is the long leg, 5 is the what? Short leg. So long leg to short leg. So the long leg is going to be what? 5 over 2. Is everybody with me on that? And now, so then that just becomes 2x equals 25. So x equals 25 over 2. Is everybody okay with that? So now let's erase that and put 25 over 2. And now I'm just looking at this triangle right here and doing a squared plus b squared equals c squared, right? So, okay, pay attention now. Let's do a fraction. Z squared is equal to 25 over 2 squared plus 5 squared. Is everybody happy with that? All right, come on now. Let's do the math here without a calculator. Okay, so we have what? Z squared is equal to 25 times 25. We should know is 625, right? And then 2 squared is what? 4 plus 5 squared is, now this is 25 over 1, right? So now, thank you, very good. So we change this to a 4, which creates this as a what? 100. So now I have z squared is equal to 725 over 4. Now, this is where I get frustrated sometimes because all I'm doing is whenever I see the number 25, I think quarters, right? If I have $7.25, how many quarters is that? How many? 29. I don't understand how people don't see that. Right? Anybody have any questions with that? Don't worry about that thing. You'll be all right. Over 4. Thank you. All right. And then we're doing what? The square root. So z is equal to, what's square root of 25? What's square root of 4? And then what's square root of 29? We don't know. 29. There isn't a perfect square in there. I'll open the door in a minute, guys. Or is he attacking you, Watson? Is that thing attacking you? Hold up a second. Go, what? Well, we added 725 plus, or 625 plus 100 and got 725. Now I'm just breaking down 725. And instead of trying to figure something out, I just go, okay, quarters, think of quarters. All right, anybody have any issues with that? Sam, you're good or you're just stretching? Well, what's the square root of 25, buddy? Now I'm asking you, what's the square root of 25? What's square root of 4? And then 29 stays home. Right? Anybody have any questions? Okay, so now again, I personally feel like that's annoying, but it's super what? I think it's super easy. All right, now what I want to do is look at the next lesson. All right, look at the next lesson. All right, let's do just for practice. We can do number 2. I think number 4, setting up the similarity statement, is fine. Do that also. Now, again, I'll give you a little break, 7, 8, and 9. I think those are all the different possibilities. I skipped number 6 because I don't like 23. All right, the other numbers are small enough, you should be able to mentally do them. All right, now look at number 7 right off the bat. Don't be confused. What's this length from here to here? There you go, 19. All right, anybody have any issues? So those are the ones I want you to do. I don't care about number 10. All right, listen though, I keep telling you guys, for those of you guys who are still not happy, and I'm saying do number 2, 4, 7, 8, 9. If you're not happy with the way things are working out, then you should probably do the whole thing. And you should go back and do everything on that page. If you do that, then you know exactly what's going on. Some people are good enough to say, wow, I can just hear it and know what you're saying. I don't need all the extra repetition. So if you don't need all the extra repetition, I'm not interested in doing that either. I'm trying to tell you, you got to know what you don't know. And it's horrible, but if you're struggling a little bit, that means you have to do what? More. All right, if you're finding all this so simple, then do the minimum, which is what I said. 2, 4, 7, 8, 9. 1, 2, 3, 4, 5. I don't think that's too much to ask. Make sure it gets done. All right, and if you're struggling, you're not 100% sure, then do all of it. All right, any questions? All right, looks like we got 10 minutes. 10 minutes should be enough to finish. All right, how's my homeschool peeps? Did all that make sense?
Yes.
Yeah. Man of many words. I like that. All right, you guys have a wonderful day. Stay out of trouble.
Thank you. Have a great day.
Bye. Have a good day.